Hi folks, welcome to a Bit Retro Journal. Right now I'm playing my elite game on the ZX81 Atomic Sinclair 1000, and you can see that it's an awfully slow game. And again, this was originally written on my QL for the ZXSimulator just to show that it was compatible, and then I could also then run it on my ZX81 Atomic Sinclair 1000, but very, very slow. And if I fire, there we go. Yeah, it's just painfully slow. So what I want to do today is, I'm actually not going to try to play this game. I want to compile it. And you did, if you saw my previous video on the MCODER2 compiler, I want to compile my elite game. However, the problem with the elite game, it's a little too big, so I can't just load it into MCODER and compile it. So I have to do a little bit of work, and I was going to show that process. I'm going to actually do this all on the Atomic Sinclair 1000. Not going to use an emulator. We'll later on afterwards we'll go to the my Windows machine, and we'll look at what it actually creates. But I really want to do it authentically, as if 1983. I was working with this MCODER2 compiler, and I've played with it a bit now and actually find it very useful. Notice that I have a printout of my code. So this is it's about 5 pages of it, and I've already marked it up. This is actually how I coded back as a kid in the 80s. I would actually didn't have a printout obviously, but I would actually write it in a notebook by hand, and then change things. And so that's kind of how I've gone about it. Is I loaded this particular game. So, what I will do right now, this is just loaded in my Atomic Sinclair 1000, but I will load it MCODER first, and then I will load this game into MCODER, and it's a little bit too big. So what I need to do is I need to actually it won't even attach itself. So the way MCODER works is you load MCODER first, MCODER2, then you load your basic, and then you attach MCODER to the front of the basic program. Well, this is even too big for that. So one of the things I first have to do is I'm going to have to get rid of you can already see that I marked it out. So this is the code that does the graphics part. So I'm going to remove that, and I'm going to then compile everything but that, and then I'm going to compile the graphics as a second chunk, and then sort of piece it together. So MCODER actually allows that feature where you can compile a piece of code and then compile a new piece of code, and they become two separate machine code routines. And I'm going to show you how you can have them communicate using peeks and pokes, and setting aside a little bit of memory. So that's on the agenda today. The first thing to do is I'm going to quit this game. And I'm going to, so the only difference is, if I were doing this in 1983, I would be using real tapes. And the problem is I don't really have a good tape player. And also I don't have, so what I'm going to do is I'm actually going to save it out to my PC. So the nice thing there is I don't have to be neurotic about it. I'm just going to save it once because I know it's going to capture the signal well. If I were doing this on a tape, I probably would save it multiple times, and this would probably take me an entire day to do, as opposed to just an hour or so. And I probably would have multiple of these tapes around. That's how I did it as a kid, because you never wanted to lose anything. But I am going to save this a few times because I am going to have to. So MCODER is going to allow me to load most of this, and I can then make the changes. But I am going to have to retype the graphics part, which is from here. So from here, so about a page of code, a little bit more than a page of code. I won't have to retype that. I'm not going to have you sit through that, but I'm going to show you the end results and then make all these changes as well. So let's do that. So I am going to use OTLA fast load for the MCODER part, but after that, you can't use OTLA fast load when you have MCODER running. The other thing I've discovered is that once you have a program in, if you the first time you run MCODER and then attach the program, it actually still has the code that attaches the compiler to the program in memory. So what you actually need to do is save it and reload it. And you'll get more memory back, and you can compile programs about 5 or 6K versus only 4K. So I'll have to do that as well. And I'll talk you through it. So let's do this first. Let me just do a new on this. And what I'm going to do is I'm just going to load MCODER2, but I'm going to use the OTLA. It's going to load like this, which is beautiful. So do that. So I don't have to go and even... here we go. And this is going to literally load in about 8 seconds. And you can see that screen. And then, so it's loaded. So now what I'm going to do is I'm going to load the my Elite. And so this is going to be the full 3-minute version. So you have to load it. And let me then start the tape here. It's loaded, and so I can list the program, list 10, I guess. And there's the whole program. So again, before I can even do anything, I need to remove some code at the end. And so if I skip to lines 3200, so list 3200, what I'm going to have to do is remove all that code. And the way I'm going to do this is just the old-fashioned way of just that. 3, 2, 1, 0. So it's going to be a little time-consuming. I'm not going to have you sit through this. So I finally removed all the graphics code, and then I did two other things. Where I originally set these to an in key, this time I'm peaking to 5 locations, and so 20500 is actually the location of the first compiled REM statement of MCODER. But what I'm going to do is I'm actually going to stick in my own REM statement of like 5 or 8 bytes, which will force MCODER to move its code further down. And then this user call here is actually for the graphics routine, and I'll show you how to figure out what that address will be after once we've compiled this. And basically we're going to have to compile this code twice. But what I want to do next is I just want to do, so the function call is, didn't hit the L. And so it's 32462 is a thing that's going to attach my code. And so if I hit OK, it's just going to, So now it's attached. So if I list 1, you'll see that, so that has attached, what it's actually attached is 0, which won't list anything. But so that's because it's unprintable stuff. But if you list, and so now what I need to do is I've attached it. I'm actually going to save it, because what I don't want to happen is I don't want to lose what I've done, because it took me some time to take that stuff out. So let me do that next. Before I do that, I'm going to go 1, and where's my REM statement? REM 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to add that in, because there's no REM statement there yet of 1. So if I do that, that is where I'm going to peek and poke information. So that's going to be my communication channel. So now let me do is I'm going to save this. Okay, so I saved it, and then the first thing I did is I newed it and loaded it right back in. And again, the reason I did that is because I wanted to clear out the part of MCODER that attaches the compiler to my BASIC, because that gives me more space, because that code that MCODER stores sort of above that sort of exists so that you can load another program, that takes up memory. So you get rid of that by reloading it. So I reloaded it. And so now I'm ready to actually run my first compile. Again, if I list it, you can see that I have, it's there, but right above that is, I can list 1. So there's no code. So this 2 REM statement is just, I'm not sure what that holds, but it's going to be deleted as soon as you do your first compile. So the way you do this is you go let L equal, And if you do 17287, that actually lets you compile it without action. And you say code tells you where do you want to compile to. If you say 0, this will just do an actual compile. And you can see what it does is it'll stop at the first error. And so one of the first errors is that you can't do equalities inside of, so if I go list 10, you'll see that. Yeah, so you can't do that. So I've already figured out how to do this. So this basically says if for 1/6 of the time I want ST to be 1, for 5/6 I want it to be 0. And so one way I can do this, the rand function in MCODER actually returns integer between 0 and 32,767 versus the rand function, RND function in ZX81 basic returns a value between 0 and 1, excluding 1. And so the way you can do this is you can say let SD equal rand divided by 27306. And so that is 5/6 of 32,767. So basically 5/6 of the time it's going to be 0 because it's integer division. That MCODER only does integer arithmetic. So the number is going to be smaller than that, so it's going to be 0. And for 1/6 of the time, the number is going to be bigger than that, so it's going to be 1. So this will actually do the same thing. And so that's first one. All right. And again, there's a whole, I'm just going to show you some of the things you have to do. 1728. But I just wanted to show you how nice this actually is. It's actually a pretty handy compiler. So the next part is going to be, yeah, you can see right here, it doesn't like, so you have another rand statement that I can fix right away. 1350, let direction equal, and here I'm going to say rand divided by, so I was getting value between 0 and 8 and 1, and basically if it was for half the time I would change direction, for the other half I wouldn't. And this is a faster game, so I'm actually going to divide it by 2048. So it's going to give me 16 different values. And so for 1/4 of the time I'm going to change direction of my enemy ship, and for 3/4 I'm not, because otherwise it wiggles around too much. 1350, so do that. And then the other one I need to change is 1370. So the way I'm going to do that is, so I can't have ORs. It says you can have ORs, but I've not figured out how to do ORs, but you can easily change those by saying if it's greater than 0 and if it's less than 63 and if it's greater than 0. So I'm just flipping around all the or 13, if it's less than 13, then it's greater than 12. And so you can do the ORs sort of by inverting everything. And less than 43. I could have done less than or equal to, but for whatever reason I like doing it this way better. Then instead of going to 1420, we are going to just skip to the next line, 1380. Oops. That's going to go to the next line. And then, so that's just going to go to the next line. And then in 1375 is where I go to 1420. All right, so it's almost like I'm doing the else, since it doesn't have an else. All right, so that gives me the next one. And let's do it again. Let L equal 17287. And yep, to 0. And it's just going to go and find the next error. And yeah, another OR. All right, so I'm just going to keep going through this and cranking away, fixing all those issues. And I will come back once I'm done to get ready to compile the whole thing. All right, here we go. So it made it through the compile, so I don't want to run it because there's nothing to run. So now I can actually compile it. So the way you do the compiling, you just say let L equal 173. Yep, so it took a while to go through and fix all the idiosyncrasies. And again, I had a couple of for routines that did a step -1, which is not allowed. Yeah, just a bunch of ORs, that kind of stuff, and all the RANs. Mostly, though, I think it wasn't too much. And yeah, it says it ends at 25027. So the next one is either going to end at 25035 or 36. And one way to sort of do that is as follows. What you can do is, I don't want to run it. You can first, so 20514, you want to remember that number. So I'm going to write that down. And so what you can do is you can now poke. So poke 20514 -6, which gets you before the rem, and it always compiles to where's my comma? Comma is that. And if I poke it to 1, then what I can do is if I list 10, and yeah, a stop stops the compilation, so I'll say 500 stop. What that's going to do is if I go let L equal 17300, it's actually going to compile, but not very much. It's literally just going to compile that twice. And there it says it's going to run it at 25035. So that's going to be the next one. So now if I get rid of the line 500, if I remove the rem statement to just create it, and then if I poke the old rem statement, poke 20514 -6 back to 2, now it's going to recompile into that. And so now if I list the routine that I need to change is 30, I think it's like something like that. 3100, right? So list 3100 and edit that. And now what I want to do is (25035), and that is going to call that routine. And so now I can recompile it. Let me just list 30. List it from here, just make sure I made the right change. It's changed. So now I can say let L, and this is just going to recompile my whole code. 17300 with the new modified. What I'm going to do is I'm going to probably fast forward over that part. Okay, it's compiled. So now what I want to do is now I have to save it. So I'm going to save it, and then after saving it, I'm going to run there's another user command to run to actually delete all the basics so that I can then type in the new basic for my next routine. So the command to type in is going to be rand user 17281, and that is supposed to delete all of the basics. So let's see if that works. Yeah. So now if I list 1, if I list 2, if I list 3, if I list 10, there's no more basic. But I saved the old one so I can always come back and change it if I need to. So now what I need to do is I need to type in the code that I deleted previously. So that's going to be a little bit of a pain. And so what I need to type in is so 3200 rem. This is for the display. And I got to type in 3205. So I finished typing in the code, and then actually the first thing I did is I actually saved it. And so what I want to do next is compile it. What I need to do first is if I actually do a list one, you'll see that I have the rem statement from my first compilation. So I need to change that. And the way you do that is you poke 20514, which is the first compilation, -6 to get around the rem statement and put 1 in there. And so now that should show 2 of those. So now I can actually compile this one. Let L equal, and just to show you that it actually, I've typed it in. So the nice thing is you can actually test it and it's running. Start, boom, right? So again, listing the whole routine. So now I can compile it. Let L and I did use the 172.287 to check that I didn't have any errors. User 17300. So this is going to create a brand new rem statement, 2 rem. So I'll have 2 rem statements with machine code. And here it is, successfully compiled. Now notice it says 25036. It's really weird. Okay, so the final thing to do is not having saved it is I want to do the command that clears out the basic again since I've compiled it. So I want to go let L, actually it's rand user 17281, and that has cleared it. So if I list 10 now, there's nothing there. And then, so now what I want to do is I'm just going to go 10, let L equal user 20514, which starts the game going. And that's it. And I can actually run it. And here's the game. And I can start it. You can see it's running much faster now. Fireworks. And notice that the communication between so just to end the game, if I just move, I kill my fuel really quickly and the game will end. There we go. There, I didn't kill any pirates. But just to show you something, list 1, you'll note that FAWDS, so those values were poked in by the graphics routine and read by the other routine. So that part worked. So what we're going to do now is we're going to go into my PC to take a look at this. I'm just going to go ahead and save this as the final step 4, which is actually my game. So here I have, so I started with these 2 WAV files. This is MCODER. This is actually an OTLA version, so it's really small. You can see it's only 8 seconds in length. It'll say 8 seconds. This one, though, is the 3-minute version of Elite. I loaded this in, then I loaded that in. And then I kept saving step 1, step 2, step 3, step 4, and I used the 81 emulator to convert these. Basically, you can load these in WAV files, and then you can use this basic listing option to then save it out. And the nice thing here is it actually shows you what it looks like. This is the last one, 4, which is the game. You can see that's the encoder, and then at one point, there's my rem statement. There's the first part of the game, and then there is the second part of the game, and finally the 3 rem statement, and then the call. What they look like here, so this one, is again just they're just basing these 2-digit hex values. Here's my rem statement with the value changed. You've got again 2 rem statements with 2 1s in a row, and then this is the routine that prints the screen, and then finally that. In the first one, you saw basically I just added the 1, 2, 3, 4, 5, and then there's the code that I added that then needed changing, but it was just connected. In step 2, I had just compiled it a second time, right? Because it had the values at the end of 25035 and the peaks. And then step 3 was where I had removed that basic code and had not yet compiled, but added in the display code, which is this stuff right here. Then step 4 is when once I've compiled it, and then I saved it, which is the final game. And you can see that this will actually run on this one as well. Yeah, so runs and fire left. Yep. So in any case, that's what's involved in doing a compilation where it's bigger, it's too big to compile otherwise. Now there is a way to actually compile this in 81 using the full 48K of memory, and the instructions were, let me go find that and show it to you. Yeah, I had asked on the forum, and Fruitcake, who actually is the creator of 81, came up with the answer of how to do it. You basically have to use this basic listing feature. So you load in the coder, you save the decoder as a basic file, then you load in your basic program, you save that as a basic file, you combine the two into a single one, and then you poke RAM-top to be 48K, and then you can load the combined program and compile it, and it'll all work. So basically, it's a little bit of a workaround, but that's how you would do it. So these instructions work very well. Yeah, so that was pretty fun to do. So here I go. I finally got my game, and it actually plays pretty well on a ZX81. Oops, yeah, you gotta definitely plays better than the original one. So I'm gonna get it into my sights. And then here I can fire. Oh, he disappeared. He only sticks around for so long. So you have to, there we go, and bring him into my sights. Fire. He does wiggle around. Fire, oops. Fire. There he goes. So I gained some of that back, and as I said, it plays a whole lot better now. And again, it still has some parts missing, which is the planet hopping. I will add that eventually. Oops. So this is just the again, if you know the game of Elite, this is the planet hopping part. There we go. This is not the. This is the between planet hopping. You know, you try to get to the planet. You got to destroy a few pirates. Right now, you have to destroy 14 and you win. But I want to basically randomize that part as well, so that you have to destroy a few pirates, and then you get into orbit, and you're good to go. So I'll end here today. Thanks for joining me. I hope you found it useful to how to compile with MCODER if your code's too big to compile it all at once. I find MCODER to be actually a really terrific piece of software, so highly recommend it. Thanks for joining me, and I'll see you soon.